Hello, class. Welcome back to chapter 17, part 2, continuing along with fluvial geomorphology. Today we're going to be taking a closer look at fluvial systems and their interactions with the landforms. It's a relatively shorter part of the chapter. We'll finish up a little bit early. I'll give you time to work on your discussion and your labs that are coming up. So last time we talked about fluvial geomorphology, and we looked at the process of water moving across the Earth's surface. Running water is the most important geomorphic force on the Earth's surface, as I mentioned before. Every landform shape you see and interact with is a product of either material being removed, erosion, or material being deposited somewhere. Erosion occurs when sediment is removed from one place by a geomorphic process. In this case, we're looking at water, fluvial geomorphology. And deposition is when that sediment that is moving stops moving and comes to a rest somewhere else. Now, we typically associate that with gravitational force moving sediment from up high down low. But the definition itself is just moving Earth, the lithosphere, to create landforms or modify landforms. So even horizontal movement counts. So if you have some time after class, please go into the Canvas file section and pull up this lecture slide and click on this link to check out some horizontal movement of these large stones in Death Valley. Pull it up in a web browser really quick. You can see that this is a very interesting phenomena where these rather large boulders are moved horizontally across this sun-baked dry lake bed called a playa. And for decades, scientists were not able to conclusively determine how or what was moving them. But after some experiments and some watching, they finally figured it out. So please take a look here at this video that's linked in the chat. I'm sorry, since I'm not lecturing, there is no chat, but in the lecture slide itself, you can click on this and follow it. So looking at erosion and deposition typically work in tandem, but in any given situation, in any given location on Earth, one of the two processes is dominating the environment. There's either more erosion going on or more deposition going on. And when landforms erode, they create things from uplifts, and these things that are created are gullies, like we mentioned before, ravines that grow from gullies, and then full-fledged canyons, which leaves peaks, saddles, and spurs in the landforms that are at higher elevation. Now we have a pretty famous saddle kind of near San Antonio. Does anybody happen to know what that is or has been down south, specifically Monterey? It's known for its saddle feature that's within this rise, this mountain that the city literally wraps around. If you're from Monterey or you've been to Monterey, you know this. You may not know it's called the saddle, but it looks just like a saddle. You can Google it. Or if you ever plan to go down there for vacation, you definitely have to check it out. It's pretty cool. I think you can even go up there. It's a national park. I'm not sure you can actually go all the way up to the saddle, but the landscape around that area is pretty well known for its ecotourism. Okay. Now, depositional landforms, where the material slows and drops out of the fluvial system, that's where we create and see alluvial fans on the landscape. And then within a river floodplain, there are features that are created by the movement of water in the river channel and during a flood event or a bankful discharge. So taking a look at fluvial erosions on hill slopes. Hill slopes are the most active zones of fluvial erosion due to the steepness of the slope Therefore, gravity's force affects the movement of water and the material that it can carry, more energy. Okay, the more vegetation there is on the hillside, the less erosion may occur because roots like to hold in dirt, and that slows down or prevents erosion from occurring. So where you have a dry or a barren slope, that's more susceptible to being washed away by fluvial action. So if you remember from the introduction to fluvial geomorphology, we showed you that image from Big Bend of the rills and gullies. So rills are formed when water breaks down and loosens sediment and results in the formation of very tiny, deep, near vertical furrows in the landscape. Gullies form as those rills eventually merge together and create wider and wider and deeper channels. It starts to spread out horizontally as the slope wears down, right? The rills form, and then as they carry more material away, the slope of the region or landscape there is reduced, and it widens out to form gullies that eventually may lead to ravines and canyons. So let's take a look at this process of streams as a land shaping process, moving material from up high to down low through erosion and then deposition. That's called stream gradation. Streams are shaped by the process of water running down, running off of the surface, eroding away the material, and then as it slows down in certain parts of the stream channel, depositing some of the material it was carrying and creating a path for it to move through the landscape, which is not fixed. It moves through time because streams adjust to their environment by balancing their load, the amount of water coming in, the amount of sediment that gets moved by the water, and then the channel size to accommodate, on average, the expected amount of water that nature, that the hydrologic cycle is delivering. So it's a balance. Things are carried away, things are deposited. Within a stream and in stream gradation, there are three ways in which streams move material, the lithosphere, down the stream channel. The first is dissolved load. Dissolve, like you've made some tea before, right? And you put some sugar in it and you mix it up, or if you feel a little sick and you need to gargle some salt water, you dump the salt in the water and mix it up, and those minerals dissolve. You can't see them, but the minerals and rocks are in the water, just dissolved, and that forms a solution. You might have done that in chemistry class. Well, eventually, when the water slows down and the solution stagnates, and then when some of the water evaporates, then the solution becomes super solution, right? Then the solubles become solids and drop out, like in oceans, and the water evaporates, or lakes, right? Then the dissolved load reappears and drops out. Second is suspended load. This is what makes water cloudy. Things that are light enough to be held aloft and mixed up with the water because of the force of turbulence. If the water is calm, the material will drop out because it doesn't have a lot of that energy in it, just like air bouncing around molecules. Water can bounce around load, small, lighter pieces that are kind of floating, not all the way at the top, but not all the way on the bed, right? And so the more turbid the water is, the more particles or the more load that river channel can carry. The third type is bed load. The material that's on the stream bed, like at the bottom, and it doesn't go up very far, but it does a little bit in one of three processes. The first is like rolling. The force of the water moves material along the bed and rolls it and bounces it. Another would be like sliding. If you've ever tried to stand in a quickly moving river, like some parts of the San Marcos River, where it gets really narrow and the speed of the water increases, you may not be able to plant your feet. It kind of pushes you, slides you along the bed there. The third type is saltation. And I'd be pretty salty too if I was picked up and dropped and picked up and dropped and picked up and dropped, right? That's saltation, where the material is not quite light enough to be kept aloft by the turbulence, but it's not so heavy that it can't not be picked up. So it's picked up a little bit and dropped and picked up a little bit and dropped as it progresses down the stream channel. That's saltation. So when we look at a stream moving across a landscape, there are different types of streams that incise themselves in different landscapes, depending on the material in which the fluvial action is moving through. For example, here in Central Texas and the Midwest, we see a lot of meandering streams, streams that carry a mostly suspended sediment. There is a movement to the water such that it can have enough force to carry a lot of sediment. That's why if you ever go across one of the bridges in the Guadalupe or the Frio or the Brazos or the Blanco or any one of these rivers, if you look down, it's kind of brownish, kind of clearish sometimes if there's not a lot of rain going on, but this is all that suspended sediment. And the more water that enters into the channel, the more energy it has, and the more sediment, more load it picks up. And as you can see, it also meanders throughout the landscape, carving channels. And we'll get to meandering in a little bit. We can also see in this photo, and I'll mention it now before we get to it, the meander scars where the river used to flow, and then it changed its course and dug into a different part of the soil on that landscape along this this hilly area here, this little slight uplift, and it's right along the edge of that where the water is coming down and collecting, and it's cutting its way through this plain area, this more flat area, a floodplain, and you can see it has historic channels that it's no longer following. The second type of stream I want to talk about is a braided stream. This stream moves through sediment that is extremely pliable and soft and doesn't really put up much of a fight to the force of the stream going through it. Therefore, the stream is allowed to eat away at the banks easily, and so it doesn't dig a very narrow channel because it's way easier to go wide than it is to go down, right? If you want to dig a ditch, it's easier to dig just to scrape the surface than it is to dig deeper and deeper and deeper into the ground. So that's what happens here in very loose soils. You get these braided streams, and braided streams are typically ones that have a constant source of water. Remember what those are called? There's two types of rivers, ephemeral and perennial. That would make this a perennial stream, okay? Easily eroded, constantly changing its channel throughout this material because it can do it with wanton ease. So back to graded streams and stream gradation, okay? There we're talking graded streams are very large streams that adjust their channel to the change in elevation over a distance, the slope. For example, the Mississippi River has been eroding or removing material from its channel and moving it down and creating the Mississippi River Delta, right? New Orleans area, all that new land comes from somewhere. Well, it comes from the Midwest United States. Not only does it wash in during flood events into the stream channel, but then the water carries it through one of those three ways, carries the load down. The process of removing material from the stream channel itself is called degradation, to degrade. Okay? And then when the water slows down and material drops out and it builds up stuff like on the delta, that's called aggradation. Deposition on the bed of the channel due to either more load that it can carry or its energy is decreased and there's less discharge going through the stream, so the material drops out. Now, streams internally adjust themselves. This is the wild things. I mean, streams aren't alive, but they interact with their environment to achieve a balance, as best of a balance as it can get. Because when it receives too much water, the channel gets dug out through degradation and materials moved away to carry more water through the channel. In times of drought, when there's not as much water entering into the channel, things aren't degraded as much. In fact, there may be some depositing material from higher up. That's aggradation. So the channel over time expects the hydrologic cycle to continue at about the same rate it does every year. And so the channel's width and depth and in slope eventually stabilizes so that it moves ideally and optimally as much water as it needs to move on average on a yearly basis. Now, then come along events like that 1993 flood that we mentioned last part of this chapter, which destabilizes the whole river channel in that area. But over time, we're talking hundreds, thousands, if not 10,000s of years, tens of thousands of years, that stream channel will grade itself back to a perfect curve of slope to move water out of the environment without moving too much or not enough. It works it out that way. Just slowly the channel works itself into the environment to create a balance. And then beavers come along and mess it all up or something, or we come along and mess it all up, right? The poor river, it's been trying to create this perfect curve for hundreds of thousands, if not millions of years. And then we come along and like one blink of its eye and be like, boop, there's a dam. We do it. So let's take a look at how the environment gets there. Stream gradation, the evolution of a graded stream. Let's actually pause right here for part 1. I'm going to stop it so the video doesn't get too long and YouTube yells at me. And then I will start back up with part 2. Cool. Once I figure out how to, here we go, stop the recording, right on.